Hello everyone, I am Dharmender Kumar Chaudhary, Assistant Professor in Department of Textile Chemistry at MLV Textile College, Bhilwara. In continuation of a video lecture of the Textile Chemical Analysis Part 1 of 4th semester Textile Chemistry branch. In this video lecture, we are continuing our lecture with continuing lecture on the topic of cross-linking agents evaluations. Before this lecture, we just discuss about the cross-linking agents, its basic property and its effect on the cellulosic fabric and its evolution in terms of identification and chemical analysis as a total solid content and free formaldehyde content. Now in this lecture we will discuss about the estimations of total formaldehyde content in any resin which is formaldehyde based. Total formaldehyde content can be determined by a strong acid hydrolysis of N-methylol product to liberate all the formaldehyde, which can be determined by different method. For example, chromatographic acid method or phosphoric distillation method. Generally, chromatographic acid method is preferred for determinations of the total formaldehyde content. In chromatographic acid method, hydrolysis of the sample by prolonged contact with 12 normal H2SO4, it means hydrolysis of a sample with very strong acid at room temperature is carried out, followed by measurement of sodium salt in a strong acid solution. In this, what we discuss is the hydrolysis of a sample with a strong acid at room temperature, and then measurement of the intensity of color produced with chromatographic acid sodium salt in a strong acid solution, as intensity of the color is directly proportional to the total formaldehyde content, and the intensity of the color can be estimated by the spectrophotometric method at 570 degree nanometer wavelength. So by this way we can calculate, or we can estimate the amount of we can estimate the total formaldehyde content in any type of resin which is formaldehyde based. Now we will discuss one of the much important characteristics of the cross-linking agent, which is nitrogen content. Before, as you know, we will discuss about the nitrogen content estimation in our previous lecture. But just here we will again revise the same thing. Nitrogen content can be estimated by the Geldahl methods, very popular methods, as all of you know. It's also studied in your previous classes in the chemistry. In Geldahl method, sample is heated with concentrated H2SO4 in the presence of catalyst to convert the nitrogen into ammonium sulfate, and after converting nitrogen into ammonium sulfate, alkali is added to decompose the ammonium sulfate and liberated ammonia, and ammonia is collected and back titrated with alkali to find out the nitrogen content. As you see in the reaction, ammonium sulfate, which is got by converting nitrogen into ammonium sulfate by addition of by reacting nitrogen based compound with acid. Then ammonium sulfate is reacting with alkali, then ammonium sulfate decompose into ammonia, and ammonia is collected, as we say, ammonia is collected and back titrated to the alkali. So amount of ammonia can be estimated via this, and nitrogen content is estimated. Now we will discuss about the formaldehyde to urea molar ratio, which is one of the most important parameter in the to decide the composition of the cross-linking agents, because as formaldehyde and urea, their ratio matters on the their ratio. As a formaldehyde and urea behave differently on the property of the treated fabric. So the choice of suitable formaldehyde to urea ratio is governed largely by the end requirement of the finished fabrics. In general, the crease recovery and drop in strength, that is tensile or tear strength, at a given applied solid content are dependent on formaldehyde to urea ratio. Loss of strength increase as proportion of the formaldehyde increase, and drop in strength is also directly proportional to the crease recovery imparted. So as the formaldehyde portion is increases in the resin, then the strength, then the desirable property like the crease recovery is improved improved, but simultaneously loss in strength, that is tensile strength and tear strength, is higher. So we can say as the content of formaldehyde is increases, the improvement in the crease recovery property is achieved, but simultaneously loss in strength is become more. Now the formaldehyde urea ratio also determine the hand of fabric. An increase in formaldehyde contents give improved springiness but a stiffer finish, whereas a decrease in formaldehyde content give a softer hand coupled with a slight reduction in fastness. So it is necessary to control the formaldehyde urea molar ratio for desirable effect of all property together by the following formula. Here the mean of desirable effect is that there is a compromise over the most appropriate effect of the crease recovery requirement. Also, up to what extent we can sustain the loss in strength as well as stiffness and softness property. So here formaldehyde to urea molar ratio can be calculated by the total formaldehyde content and nitrogen content, which were estimated as we discussed just now. So total formaldehyde content, that is X multiplied by 14 divided by N, that is nitrogen content, into 30. So we just discussed about how to calculate the formaldehyde to urea molar ratio, and formaldehyde to urea molar ratio is a number which give the basics idea about how a cross-linking agents behave in terms of crease recovery angle improvement and extent of strength loss as well as stiffness and softness of the fabric. So just now we have discussed all the characteristics, all the basic characteristics of any cross-linking agent. It may be chemical analysis part or identifications, that is just a testing of a cross-linking agent before applying on the fabric. Here now we will discuss about the performance of these cross-linking agents. So the performance of the cross-linking agent can be determined or can be assessed by applying the cross-linking agent on fabric surface. After applying the cross-linking agents on fabric surface as per recommended by the supplier of the cross-linking agent, or we can say the proper condition of the application, The cross-linking agent is applied on the fabric, which is then tested for the crease recovery angle, tensile strength, tearing strength, abrasion resistance, wash and wear behavior, and chlorine retention in some cases. So after assessing these properties, we can just summarize, or we can conclude the effect and efficiency, and we can say effectiveness of the cross-linking agents in the finishing treatments. So now we had discussed all the important characteristics and parameters for the evaluation of the cross-linking agent. Thank you very much.